We have batteries, different types of batteries here. Most commonly used ones, lithium polymer or LiPo. I have an LiFe, Fe is iron, so Lithium-Ion, just there. NiCAD and NiCAD as well. I do have an NiMH, which is nickel metal hydride battery around here, which looks just like that, but I can't find it. Okay, with batteries, with your normal alkaline battery, normal one you buy from the shop, AA or AAA, each cell is 1.5 volts. For NiCADs and NiMH, the voltage is 1.2 volts, so you have less voltage for the same size. They come in packs, so these are joined end to end logically. Physically they're side by side, but the negative here will be joined to the positive there, which would be joined to the negative here, so forth. So each of these is 1.2 volts. So this 4-cell pack gives me 4.8 volts, which is what I needed to power my receiver, because my receiver couldn't handle more than 5 volts, or else I'd fry it. NiCAD, they're not very environmentally friendly when you finish with them. They dispose of them properly. Back in the day, they could deliver high current, so some of the flyers who would have like a 10-second motor run, this could, the proper NiCAD battery could deliver like over 100 amps, and the aircraft would climb like there's no tomorrow. So they can deliver high current, but really they're in a metal can, they're heavy, they've had their day. This bunch of NiCAD there's 8 in here. This is for a transmitter pack. I'm not using that anymore for anything. Nickel metal hydride is the same. The problem with NiCAD was that it would have battery memory. So when you discharged it, if you discharged it down to say 50%, when you recharged it, it would think that it's only 50% of the capacity of what it used to be. So when you discharge these, you'd have to take them all the way down so that they'd remember that they're this big, they've got 100% capacity. If you didn't, they start thinking that they have less capacity. They're shorter people. Then they bought in nickel metal hydride, NiMH, which had no battery memory. So you could take them down, maybe use them 1/3 or 2/3 or half or whatever, and you can still charge them up and they still remember that they were a certain capacity. This is the size, 600 milliamp hour, and I'll explain milliamp hours when I get into the lithium polymer batteries. Say goodbye to NiCAD and nickel and NiMH. Okay, LiPo, lithium polymer battery. First thing, safety. You don't charge them inside your house, you don't charge them inside your room. They can catch fire, they've been known to detonate. After a crash, if they're bent, keep them outside and watch them, feel them to see if they're getting hot. When you charge them, keep your eye on them. You can get fireproof bags, which I don't think are very fireproof at all. And I just like, when I charge, I like feeling them all the time and listening to them. If they're going to cook off, have some sand in we have a container of sand nearby, which is a cheap fire extinguisher. And we also know where the proper fire extinguisher is. But you'll hear them start sizzling. Like this has been involved in a crash, and you can see it's a little bit distorted. If I was to charge it, I'd keep my eye on it really carefully. And if I hear it sizzling, if I feel it getting warmer than room temperature, I'd take it outside and I'd watch it, then I'd dispose of it properly. We discharge these with a 12-volt light bulb plugged in. Don't throw them in salt water to discharge them, because that just corrodes the contacts, and then you can't discharge it after that because they're too corroded up in there. So attach a light bulb to it and just discharge it fully, or throwing it away. Now, each Lipo cell is 3.7 volts. So there's 3 cells in here, 1, 2, 3. Physically put side by side, but logically put end to end. Positive to the negative, goes up to the positive to the negative, goes up to the positive to the negative. So 3 times by 3.7 is 11.1 volts. So total voltage of 11.1 volts. However, that's its nominal or normal voltage. However, this 3-cell LiPo battery will actually charge up 12.6, because each cell charges up to 4.2 volts. You actually get more bang for your buck. So it'll go to 12.6 volts, and that's full capacity. when you charge it, make sure you get an intelligent charger where you set the battery technology, LiPo. You set how many cells, 3-cell lithium polymer battery. It tells me here, really hard to see, but it says 3-cell, 11.1 volts. Another way to see is on my balance lead here. There's my 3 cells and my common earth. So that tells me it's a 3-cell battery. If this was a 4-cell battery, there would be 4 wires plus the earth. 3-cell battery, you can see it there. That's my main power lead to supply power. But I always balance charge these on our chargers, our intelligent chargers at school. This plugs into a different port, that plugs into the main charging lead, plugs into a different port, and it will look at each of the cells and bring them up to be the same voltage. Okay? If one cell is lower than the other cells in voltage, it'll stop charging that cell and bring that cell up to match it. So I always balance charge. Really, you should just do it every 3 or 4 charges probably. I do it all the time just by habit. If you just charge through that, eventually these cells would become unbalanced. So I might have the first cell might charge up to 4.2 volts, second one 4.2, the third one might only go to 4 volts. And that's its capacity. And when this thing reaches the capacity of that one, it would not charge those ones anymore. So they would not come up to capacity. Your battery would underperform. Really, these things are like performance. A good battery that you look after means performance for my aircraft. Right, so 3-cell, 11.1 volts, 3.7 volts per cell, but actually you can charge them up using an intelligent charger to 4.2 volts per cell, which takes it up to 12.6 volts. Balance charger there. Now this is my capacity of the battery, 2.2 amp hours, or if I move the decimal point 3 spaces, 1, 2, 3, it would be 2200 milliamp hours. That means, that's the capacity of my battery. That means if my electric motor drew 2.2 amps, this battery theoretically would last 1 hour. If it drew twice that amount, see 2.2 amps is not much, it's going to draw a lot more than that. Twice that much, 4.4, it would last half an hour, 30 minutes. If it drew 8.8, 15 minutes. If it drew, what's that, 8.8, 16, 17.6 amps, half of that again, which is 7.5 minutes. Now you'd be drawing probably, depends on your aircraft, but up around 20 amps probably. So your time comes down for this battery. So that's amp hours, really important for working out endurance of the system. The voltage, 3-cell, is the power, how fast the thing's going to go, which is performance in terms of power. But this number here is milliamp hours, is capacity. It's how long it will last for. Which brings into play this bigger battery. I'll ask you how many cells it is. Look at the balance lead. I've got 3, so it's 3-cell lithium polymer battery. It's common earth. But notice it's a 4 amp hour battery. Quite swollen. We've abused this battery, running it too hard, and I think there's oxygen gas has been created inside. We've discharged it, so it should be quite safe, but I'm still going to treat it quite gingerly, even though I've fully discharged it. It'll never live again. So it's 3-cell, it tells me that there, but you can, when you buy these things, you can barely see the little text mark on 3-cell, but you can count your balance lead. But it's physically bigger because it's 4 amp hour. Okay, it's almost twice that. It's going to last twice that long, but, look at the weight difference too. So you can get your aircraft and start, I want the thing to fly longer, and put a same voltage cell battery on it, but bigger capacity. But at some stage, the weight's going to start dominating the power weight endurance equation, and the thing eventually won't take off because it's too heavy. It's got too many batteries, even though it might theoretically make it fly for longer. So once again, if this battery here drew 4 amps, it would last 1 hour. If it drew 8 amps, half an hour, 16 amps, 15 minutes. If your engine's drawing 32 amps, what are we up to? 7.5 minutes. And if it's a drone, I got 4 motors, So you divide by 4 again if each motor is drawing that amount. So voltage and capacity, easy. Number of cells. If there was 4 cells, you do the math. It goes 4 times by 3.7 volts. What's that? 40. It goes 11.1. 14.8 is 4 cells, and it would charge up that little bit more. 5 cells, 6 cell batteries, and they get bigger and bigger. Big, store lots and lots of energy. Lithium polymer. This one here is LiFe, LiFe, lithium-ion, and you can also get Lithium-Ion, lithium-ion, and I think your DeWalt tools, power tools have lithium-ion, ION, but this is Fe. Each cell in lithium-ion is 3.3 volts. There's 3 cells in series. Once again, there's my balance lead. So this charges up to 9.9 volts, but when I actually charge it up, I get a little bit more bang for my buck, as mentioned, and it goes to 10 point something. Okay, but these are, I don't know much about these, but they're a lot safer. Now, there's another figure in here called C, capacity. Okay, so, and here it says 30 to 40 C discharge. That's how many amps you can actually pull out of this battery safely. I can't read this one, but it could be like 20C, 25C. At 1C, this battery can deliver 4 amps, 1 times the capacity. I go full throttle. If this is a 1C battery, which is not, it would deliver 4 amps. Okay, but if this was a 10C battery, it would be able to deliver 4 times that, so 40 amps. So if I went full throttle and this was a 10C battery, the battery could deliver 40 amps, which is, which is performance for my aircraft. So that's if it was a 10C, 40 amps. But this is 4 times that again, so it's 160 amps. This can deliver up to, this battery can physically deliver 160 amps in a burst. Continuously, it's 30C. So I get the 30, multiply by that, by the 4, it's 120. This can deliver 120 amps continuously. If I go to full throttle, it can deliver up to 160 amps. But it'll only do that for about 10 seconds, and you'll feel your motor come off, start sort of throttling back, because it can't deliver, 40C, 40 times by that continuously. That's your continuous figure. This one here, I don't know what it is in terms of C rating. This one is 30C, so that would be continuous. Okay, so let's say that's around 2000 by 3, so 60 amps continuous. It could, yeah, so that's 2.1 amps, so that's about 2 amps. By 30 is 60 amps continuous it could deliver quite happily. Anymore, there's probably a burst rating here. It could probably go over, but it wouldn't be able to deliver that all the time. For about 10 seconds, then you're physically, and you're killing your battery anyway, flying around full throttle all the time. Most important thing to remember is safety with batteries. Get an intelligent charger, voltage, balance charging, capacity of the battery, how long it'll last for, working out your endurance. If you've got a quad rotor, then you've got to divide by 4 again. If you've got a hexacopter, you've got to divide by 6 again. If you've got an octa, you've got to divide by 8. And so that's endurance and the capacity of the battery. Okay, how many amps it can deliver continuously or burst, and they'll be written on the battery. Okay, treat them with respect.